Hey guys, and welcome back to Chapter 9 on nomenclature. Today we are looking at how to use polyatomic ions in naming ionic compounds. So, yesterday in the last video, we looked over how to come up with a list of polyatomic ions that looks like this. We got a crazy list going, and you should be able to make that list on your own. Now we're going to be using that list. The list is also always available to you in your textbook. I will have my own copy of the list here for reference. Whatever list works for you, just make sure you have it on hand. You should have that and your periodic table all within your arm's reach to be successful at naming. So we were looking at polyatomic ions. Remember, those are multiple atoms held together covalently that have an ionic charge to them, and so they act like ions in compounds. So this is a big list of them, and this is another way to write it. So a few things you can notice. One is that the ending IDE refers to a single non-metal atom that became negative. An example of this might be something like N3 minus. N3 minus is given the term nitride. So once again, my IDE ending refers to the fact that I am looking at a single monatomic ion, a single nonmetal atom. If I have an ending of ATE or ITE, I know that I am dealing with a polyatomic ion, which is a nonmetal with oxygen. And this is something like nitrate or nitrite with a nonmetal and oxygens. So we can see the endings. This is an ATE ending nitrate. This is an ITE ending nitrite. And of course, though, if we don't have any oxygens, then we just have the ending IDE nitride. Please note that ATE, ITE, IDE ending is definitely something I am testing you on the assessment. So it is really important that you take the time to maybe listen back to what you just heard and make sure that you're very sure that anytime it's a monatomic non-metal, you are putting IDE, and that the ITE and ATE endings are only applied to polyatomic ions. So just make sure that's all really clear in your mind. So here you can see all of the lists of polyatomic ions that we had been over before. We have nitrate and nitrite. We have chlorite and chlorate, and then remember perchlorate, which is even more chlorate, and hypochlorite, which is even less chlorite. Sulfate and sulfite, carbonate. Hydrogen carbonate is sometimes called bicarbonate, is another terminology that's used for it. Phosphate and phosphite, hydrogen phosphate, dihydrogen phosphate. Remember, each bringing their charge closer and closer to neutral with every hydrogen that's added. We have hydroxide here, and this one is one that was not included in our list from yesterday. It is peroxide, but please make sure you have it written down. It does show up sometimes. It's O2 2 minus. We have chromate, CrO4 2 minus, and dichromate, Cr2O7 2 minus. And then, of course, we have acetate, cyanide, permanganate, and ammonium. So it's a good idea to have this list available to you. This is the same list we made in class yesterday, and we're going to be using all of these polyatomic ions now to successfully name and make formulas from our different ionic compounds. So we're starting with our practice here, where we're going to take the chance to take the individual ions and come up with their formula and then name them appropriately based on the names of the individual ions. So the first part of this, and I want you guys to try this on your own, think it through, we are going to be crisscrossing these two compounds. So for the most part, if we can, we just leave the polyatomic ion alone. So if we imagine a situation where we did Na plus and Cl minus, imagine that we were doing Na plus and Cl minus We all know how that would look. We would crisscross those and we would end up with NaCl. Well, we are going to treat NO3 or nitrate just exactly how we would treat chlorine. So we're going to crisscross these and we simply end up with NaNO3. Simple as that. 1-to-1 crisscross and we're done. In order to name it, we start by naming Na. The name of Na is sodium. And then we name NO3. NO3 is nitrate. This is why it is an excellent idea to have your polyatomic ion list available to you and be able to find nitrate NO3 because we're just going to use that exact name to put down here. For the next problem, we have NH4 plus and Cl minus. Again, we're able to just crisscross these 1-to-1 ratio. And so all we need to do is write NH4Cl. Again, just keeping everything even, 1-to-1 ratio. And the name for this, we name the two individuals. So the name for this is ammonium chloride. Notice my ending on chlorine is IDE because I'm not talking about chlorate or perchlorate or hypochlorite. I am talking about just plain old Cl minus, and just plain old Cl minus has the IDE ending. For our next Mg2 plus and SO42 minus, we would crisscross and reduce these. So our 2 to 2 cancels out and we end up with, once again, just MgSO4. And the name of MgSO4, we name Mg, which is magnesium. And then we name SO4 sulfate. Now it's time to do the next one, Al3 plus and PO43 minus. Again, my charges are going to cancel. So I end up with AlPO4. And I name it aluminum phosphate. Aluminum phosphate. So great job so far naming all of these. We're going to now throw something new in here. This is an area for something new. So let's think back again to our original example of NaCl. And let's try another reminder. Let's try Mg2 plus and Cl minus. And what we would do for that is we would crisscross them, right? So we would end up with MgCl2. Well, if instead of Cl2 we have OH minus, we just treat it the same way. So we want to do Mg and OH, but I can't write OH, Mg, OH2. If I write that, the 2 only applies to the hydrogen and not to the whole thing. And I want 2 OHs. So I am going to put OH in parentheses and put my 2 outside. This way, the 2 applies to the entire OH. We are going to go over this more on the next page, but for the moment, let's just name it. The name of Mg is magnesium. And OH, again, you can look it up if you need to. OH is hydroxide. We just leave the name exactly as it was, magnesium hydroxide. And there you have it. Okay. Okay, so we're going to do some more practice because certainly this parentheses situation is something that is new for us. So let's go ahead and try the ones on the next page. Okay, so these are many that have to do with using polyatomic ions that may have some subscripts. So when we crisscross Ca2 plus and Cn minus, we want this 2 to crisscross down. So we're going to have Ca and then parentheses to protect the Cn, And then on the outside of that, we'll put the 2. CaCN2. And the name for this, the naming is the easy part on these ones. The name for this is calcium cyanide. Calcium cyanide. Okay, for the next one, NH4 plus and S2 minus. Again, we crisscross. This time NH4 needs the parentheses because we need 2 of them for each sulfur. And we call this one NH4 is ammonium, and sulfur becomes sulfide. So ammonium sulfide. You can easily start to see how difficult this would be if you did not know your polyatomic ions. So once again, as important as having your periodic table with you for this test, you need to make sure you have the polyatomic ion list. For our next one, H2 and O2 minus, remember this guy right here, O2 2 minus is peroxide. I let you guys know that earlier in this video. First off, when we crisscross these, we end up with H2O2. When we crisscross those, this 2 becomes the subscript for hydrogen, H2O2. And this guy's name is hydrogen peroxide. And you probably know about hydrogen peroxide. You have it in your first aid kit. You know that hydrogen peroxide kills bacteria. And so if you have a cut that seems to be infected, hydrogen peroxide is a good thing to use to try to clear that up. Okay, go ahead and try the next one on your own. Crisscross them. Put parentheses if you need to. And we end up with SR parentheses, ClO4, close parentheses, 2 on the outside. And we call this strontium, and then ClO4 minus is perchlorate. So strontium perchlorate. The next one, crisscross and reduce, and you should get Ba3 parentheses, PO4, close parentheses, 2. If you got that one right, I want you to pat yourself on the back, little snaps for you. You're doing it, you're getting them right, you're doing a great job. If you did not get that one right, make a note to yourself about what was confusing about that or what you don't understand, and make sure you ask me when you see me in class next time. That's why I'm there. The name for this one is barium phosphate. Barium phosphate, just like that. So you guys are doing a great job. We have now applied our polyatomic ions to almost all of our ionic compounds. There's one group left, and they are the D and P block metals. So if you recall, those are the ones that may or may not need a Roman numeral to indicate their charge. So we are now complicating this to the maximum level of complicated. So in terms of our ionic compounds, we said we were taking steps up as we went. This is like the top of the staircase, guys. This is the last piece. So please, as you're working on these, try to solve them on your own. And if you're having questions, make sure you write them down so that you can come into class and ask me as soon as you see me when we get back to class. Looking at D and P block metals plus polyatomic ions all put together into these big questions. So first off, when we're starting out, crisscrossing for the formula here doesn't really change in its difficulty. We're going to crisscross and reduce. That leaves us with a 1-to-1 ratio of CrSO3. No need for parentheses. Fight. We did not need any parentheses on the outside of sulfite, so we were able to just leave it. Now it comes time to name, and we start with chromium here, and chromium has a charge of 2. So we put the 2 in parentheses, chromium 2, and then we name the last polyatomic ion there, and we have sulfite. So one bite at a time, not too terribly difficult. We just take it one piece at a time. Here is our next one. We're going to take nickel, Ni3+, and what's this one called? This is acetate. So we have nickel and acetate. And so we're going to crisscross them first off, and we end up with NiCl. CH3COO3. So that is our nickel acetate. And then we call it nickel, but don't forget we need our parentheses there, nickel 3 acetate. And the important thing to remember here is that the 3 plus from nickel is where we get the 3 in our parentheses. Those two coordinate. 2 more left to go. We are going to crisscross these ones. So we end up with Fe parentheses HCO3 close parentheses 2 on the outside. And this one is called iron 2 hydrogen carbonate. All of that, right? Iron 2, because iron needs to indicate its charge. And then HCO3 is called hydrogen carbonate. And some places call it bicarbonate, so you could see this written as iron 2 bicarbonate, but on your test it will be written as iron 2 hydrogen carbonate, because we're going to stay with how your book describes HCO3, which is as hydrogen carbonate. And last but not least, Pb4 plus and SO42 minus. This is a super tricky one. We're going to take it one bite at a time again. So we start out with our initial formula here, which we might predict to be Pb2 SO4 4. But this is leading us with a 2 to 4 ratio. That's my 2 to 4 ratio, and I can reduce that to be a 1 to 2 ratio. So I can rewrite this, reduce to be Pb SO4 2. Pb SO4 2, final answer. And the name for that, Pb, is lead. Lead, parentheses for my charge. My charge is 4 plus, lead 4. And then SO42 minus is sulfate. Lead 4 sulfate. I hope you guys are proud of what you're learning right now. This is complicated, and if you're following along, you're really truly doing a great job. I'm really proud of each of you. So at this point, you guys have really mastered naming ionic compounds. There's one special kind of ionic compounds called acids, and we'll look at their rules on Wednesday, and we'll follow up on Thursday with naming molecular compounds, or those compounds held together by covalent bonds, which will be our topic for Thursday. And then just lots and lots of practice. You guys are doing a great job. You're learning this information. Keep up with the practice, and you can start working on part C of your worksheet. Part C applies D and P block metals to polyatomic ions. All of this worksheet, A, B, C, D, and E, will all end up being due on the day of your test, which is on Tuesday. So you have a week from today to get this whole entire worksheet done. The more you pace yourself, spend a little time each day, the better off you're going to be. Any questions that you have on the worksheet or on the notes that you just learned, please write them down, bring them to class. I would be happy to go over any of these examples with you in class when I see you next. All right, you guys, take care, and I will see you soon.